All right, so welcome. This is the Forecast Looks Bright Tableau Forecasting. I'm Jason Miller, and this is my colleague, Joshua Rao. We are both sales consultants in the Midwest, and both of us are based out of Chicago.
So, was there going to be a clap for Chicago? Woo! Okay, yeah, awesome. So what are we going to be talking to you about today? Well, Jason's going to come up first, and he's going to be talking to you a little bit about what can we do in the product natively today using some of our drag and drop methodology, and then how can you better understand what's actually going on and some of the bells and whistles and the knobs that you can turn and tweak to kind of better format that for your own analytics. From there, I'm actually going to come back, and I'm going to talk to you a little bit more about what we can do when we use some of our external service clients, so MATLAB, Python, or et cetera. Now, this being Friday, I'm sure a lot of you've been to multiple sessions. We do like to kind of take a moment at the beginning just so that you can learn a little bit more about us, who you're going to be spending the next hour of your life with. So I'll just kind of kick this off. The very first thing you should probably know about me is that I absolutely adore dogs. These are my two dogs here. That's Bowie on the top. Thank you. That's Bowie on the top. That's Ripley on the bottom. And this works out great for me because I was fortunate enough to marry my beautiful wife, Molly, who happens to be a veterinarian. So there will always be dogs in our house. In the last two pictures, that's my daughter, Ayla. They're on the right-hand side. She's 2. And again, this being Friday, maybe you've been to a few sessions. Maybe you've been to some Tableau Doctor sessions, and you're thinking to yourself, I've seen that guy before, and he seems to be everywhere, or he changes clothes a lot. Don't worry, you're not crazy. I'm actually an identical twin. My identical twin brother, Adam, is also a sales consultant here at Tableau who's been presenting. So truth be told, in that picture there, I actually don't know which one I am. Just pick whichever one you think is cuter, and that's me. And also kind of a little bit of a gotcha moment, that's actually not me holding Ayla in the right-hand side. That's actually Adam. So with that, I'm going to turn it over to Jason to get things started. I'll see you guys in a little bit. Thanks.
All right, thanks, Josh. So Jason Miller, native of the Chicago area. Those of you that were clapping, I'm actually from the suburbs. Some Chicagoans make a big deal about that if you say you're from Chicago. So I'm a native of the Chicago suburbs. Actually, this picture was taken about 4.5 years ago after we moved back to the Chicago area. I had just started working for Tableau, and the future was definitely looking bright at that time. My kids, they're about 9, 8, and 7 now, and it's been awesome the last 4 years. This is us 3 years prior. So this was actually in Washington, D.C. at the Smithsonian. This is actually Photoshop. My littlest one, I think, is 7 months there, so she's not even walking yet. But I had just started with my previous company, which was doing integration and analytics work with the federal government. But this is actually a second career for me. So for an introduction, I want to kind of take you guys back about 14 years to 2005. I had recently graduated from college in 2003. I was on the 7-8 year plan with a psychology degree. And for those of you that knew the forecast at the time, for someone, a bachelor's with a psychology degree, the career and the salary forecasts were not that great. So I had just thrown my resume up on Hot Jobs. I don't think LinkedIn was a thing at the time, Career Builder. And I was very surprised that I got a lot of responses just for generic business and sales. And a lot of them were in mortgages. And I was a pretty naive college student, really knew nothing about the housing industry or mortgages or anything. So I went on some interviews and like, wow, these jobs pay a lot of money. So took one. Fast forward 3 years later, I'm working for the third largest subprime mortgage lender in the country. So this is the S&P 500. This is the stock market at the end of 2015. These were our financials. So we were actually owned by H&R Block. We were a subsidiary. And we had just posted record-breaking earnings in the second quarter. We were told that over 90% of the earnings were just from the mortgage company. The H&R Block stock price was at an all-time high. And the fundamentals of the housing market were absolutely on fire. Housing prices were at all-time highs. They were increasing, some places in California, 100% per year. You had all-time high homeownership rates and all-time low foreclosure rates. So by all measures, and all of these forecasts were done with Tableau. Most of these are actually very good forecasts. They show that they reduce the error quite a bit from a naive forecast, and I'll kind of explain how that works. But despite that fact, as I'm sure all of you know, every single one of those forecasts turned out to be wrong. So by the end of 2008, the housing market had imploded. Half of the subprime mortgage lenders were out of business. You can see that perfect, heartbeat trend and seasonality from the quarterly earnings was just ruined with a $500 million loss from the mortgage company. So the forecasts were clearly wrong, all except for one. The stock market at the end of 2008 was still going strong. So the housing issues had not quite yet trickled over, and that leads us to one of the most infamous economic forecasts probably in history. This was in January 10th of 2008. Ben Bernanke, who was the chairman of the Federal Reserve, made the forecast or the statement that the Federal Reserve is not currently forecasting a recession. And why is that funny? Because we were at the very start of the worst recession in history that year that would be later dubbed the Great Recession. Oh, I'm going the wrong way. There you go, that's the drop. All right, so it dropped faster and farther than it even had in 2001. All right, so why did I sort of share that little tidbit? One is to point out that forecasting's hard. So all of these forecasts, even if we had developed the perfect forecast that was tuned and tested perfectly, it's still inherently based upon an assumption that your past and current events will accurately predict the future, and whether or not specifically trends and repeating patterns called seasonality will. Absolutely no way, looking at the data that's available here for the earnings, that you could possibly predict based on the model that the next month the profits would tank into the negative, right? So, and that's specific to Tableau that does univariate forecasting. It's even more strict. So kind of what you see is what you get. So here we're looking at the H&R Block quarterly earnings. We are basing our forecast strictly off the earnings. Can't take anything else into consideration. So the forecast models were good. It just didn't arrive at the appropriate outcome. All right, so I'm going to jump into forecasting in Tableau with a demo. All right, now the first method of forecasting in Tableau that I want to show is actually just using calculations or table calculations. So this may be something that many of you have tried, and you may have come up into a roadblock. There is sort of a little trick that I'll show you that kind of makes this possible. But I'm going to start off by looking at my sales by month. Okay, that looks great. And what I want to do is my sales manager's leadership is saying that we expect a 30% increase next year. Could you please forecast our revenue out 30% over what we did each month last year? So I have a calculation here. This is a table calculation which is most likely what you will be using, because what a table calculation allows you to do is to look up or look at a window prior, which is exactly what we want to do. We want to look at January's value last year, raise it 30%, then look at February's last year, raise it 30%, et cetera. So I have a table calculation. This just checks that the order date is after the latest date in my data. I look up 12 periods prior, which would be the year prior that month, and then I'm going to multiply that by 30%. Hit apply, and then I'm going to drag out that forecast calculation. All right, you can see it did nothing. All right, so the trick here is with a table calculation or any other type of calculation in Tableau, Tableau needs those date values in the future to work with, right, to input into the calculation. Since I don't have any dates, I'm going to have to create some somehow. So in this situation, I'm just going to union with another table of data, and all that I've put into this table is the column with the order date that I'm using, and then I added a few of the measures with zeros. Really, the only thing necessary is the order date. It just makes things a little easier when you're not having to deal with nulls. So you can put any value in here you want. The main idea is just to get a date for each month in the next year. So I will go ahead and create that union. And now if I go back, you can see that I've had these zeros added to the sum, and then I'm able to calculate the forecast because I do have those values in the data. And then I can actually color this by whether or not that is the forecast value or not. Great. Okay, so that's just a simple way of using a table calculation. If I wanted to make this interactive for an end user so they could change the percent, all I need to do is show the parameter, and I am going to replace this 30% with my parameter. All right, and now if I wanted to do 150%, I could do that, or I could do 0%. And that's going to give me exactly the values that we had last year for those months, that portion in the seasonality. And I'll kind of leave this one up here because this is actually a special case that we're going to run into later. So this is what you would call for a seasonal, for a data set that has seasonality, this would be a naive forecast. So all we're doing is we're taking the last value from the last period and forecasting that over. If this didn't have seasonality and it was just sort of a line, then the naive forecast would be just the final value straight across. Okay, and when we look at the quality metrics, most of the quality metrics are measuring the difference in error between the naive model, which we're looking at here, and the forecast that Tableau comes up with. Okay? All right. So now I am going to jump into the forecasting that probably most of you are more familiar with. Let me get a show of hands. How many people in here have created a forecast in Tableau using the analytics pane, sort of drag and drop? Okay, I would say 80, 90%. All right, how many of you that raised your hands have actually used that forecast, or has somebody that you know of used that forecast for any type of business decision? Okay, so still a decent amount. I'd say it dropped down to maybe 20%, but that's not surprising to me. I think there's probably two reasons. One, as I'm about to show you, Tableau makes it incredibly easy to create a forecast. And I think inherently it's human nature to kind of dismiss something that seems very easy. So I'm hoping to sort of dispel that and give you guys confidence that these really are good models that you can trust. And then the second component of that that's obviously related is you just don't understand it. So how would you know whether it's good, whether it's a bad model, et cetera. So my goal here in the next 10, 15 minutes is to get you guys familiar and a basic understanding of how Tableau does forecasting, and then whether or not you can trust or be able to tell how good that forecast is. So whether or not you can trust it or not. Okay? All right, so we'll take the same data and create a forecast with Tableau's built-in forecast feature. All right, and we have this little tail of data. We can just exclude that. All right, and now I will go to the analytics pane. I will go under model to forecast and drag that out to add a forecast. And that's really it. So if this was a talk on how to create a forecast with Tableau, that would be about it. But that's really, I don't feel, where the value is. The real value is when you right-click on the forecast, go to Forecast, Options, and Describe Forecast. So this is where you can configure, obviously, some of the options settings for forecasting, and then Describe Forecast is where it tells you the error and what type of forecast was created. So if we start with forecast options, you can see that Tableau has made automatic decisions on a number of items. So one, the forecast length. So by default, it's going out to 13 months. If I wanted to change that to 3 years, I can do that. Okay, the aggregation. So by default, Tableau will ignore the last period. The reason for that is it's very common for data in your last period. So let's say we're getting sales data every day. It's still November. I'm not going to want to create a forecast based on November's numbers because it's not a full month yet. So in this case, I happen to know that we have a full month of data, so I can change that to 0. And then the last part here is the forecast model. So just a real quick sort of primer on exponential smoothing algorithms, which is the type of forecasting model that Tableau uses. I'm going to switch back over to my slides here. And as you can see here under custom, there's 2 primary components. One is the trend, and one is the season. All right, so if we look at just the trend component, that can be none, additive, or multiplicative. Now the trend is the overall long-term trend of the data. Is there no trend? Up or down, that would be none. Is there an additive trend? That would be essentially a straight line. And a multiplicative trend would be essentially a curved line. So with multiplicative, because you're multiplying the coefficients as you get farther and farther away along the time series, the magnitude goes up. So you're going very strong. That leads to the curved line. If we look at the seasonality component, so that is the repeating pattern. So typically, like with monthly data, you would have a pattern repeating every 12 months, with quarterly, every quarter, et cetera. And those two can be additive or multiplicative. So an additive seasonality is going to be relatively constant or raise sort of linearly, whereas multiplicative, the farther down you get, the larger the spikes will get. And when you put those together, you're left with 9 different combinations, and these are the models that Tableau evaluates, calculates the error on, and then determines which is the best model to use for the data. Okay, so those are 9 different exponential smoothing algorithms. Now you'll see in the documentation, just as sort of a point of trivia, we say that we choose from 8 models. So the one that we don't use, I had kind of assumed was none, but that's not the case. That's actually a simple exponential, that is the simple exponential smoothing algorithm. The one that we don't use is the multiplicative additive, and the reason for that is that that particular combination tends to be the math is just unstable, so it doesn't do well. So you can actually look that up. It's not typically used. Okay, so we covered the forecast model, and then the last portion is the error bands. And the error bands, you can specify whether you want to show 90, 95, or 99, and that indicates if it's within the band, you're 95% confident, for example, that the actual value will be within that band. So sometimes they're pretty broad. And that is determined by the model that is selected. All right, so let's do another forecast with profit this time. And let me look at the same profit by month. Okay, and I actually want to do the continuous month. All right, great. And let's create a forecast. All right, so you might look at that forecast and say, that's not a good forecast. It's a straight line. I mean, what good is that? Now, as I mentioned earlier, Tableau is automatically evaluating all of the possible models and selecting the best one based upon which model fits better. So essentially what Tableau is saying here is I can actually go in here and I can force it to do some seasonality. So I can go now from automatic to custom. Let's say there's an additive trend. There you can see the overall is going up, and then seasonality, let's say, is additive. And that looks better to me, but does that really fit the data? And I can tell you straight out, no. And I'll show you how you can tell. So the second most important screen, I think, on the creating a forecast is the describe forecast. So this will actually tell you a summary of the forecast itself. So I can see that we're ignoring the last month. There's a 12-month seasonality. This is the initial value. I can see that 1% of the value is contributed from the trend, 99 is the season. And then if I go to the model, there's a lot of information here. So if we look at the first component here, you have the model level, trend, in season. So the trend in the season, we've already discussed, but the level, that's simply, you can think of as where it's going to start the forecast. So that's kind of the base value, and then it applies the trend and the season above that. In the second portion, these are the quality metrics. I would say for all intents and purposes, you can just ignore the first two. Those are measures of error, but those will vary depending upon the magnitude of the data. So if you're dealing in billions of dollars, it'll be in billions or millions. If you're dealing with tens of dollars, it's going to be in single digits. The last three, the MACE, the MAPE, and the AIC, those are all normalized. So with the MACE and the MAPE, the closer to zero those are, the better. They will both either at 1 or 100%, that is the same amount of error as the naive forecast. So it's almost like a guess. And sometimes you will see it above that, but essentially the lower the value there, the less error. So when I look at the MACE value, that's the mean aggregate squared error. It will, what that's telling me at 0.5 is that I have 50% as much error in this model as I would with that naive forecast. So if I just took the last value from the last period, this is 50% better. Okay? And then the last one, the AIC, which is the ACACE information criterion, that is similarly used to compare models, and the lowest value is chosen by Tableau. This is the value that Tableau actually uses, and this one also includes a penalty for more complex models, so it prevents sort of overfitting. So that's where we're going to use the lowest value. And then the smoothing coefficients, these are the determination of how much smoothing is done. So the closer to 0, the more smoothing. The closer to 1, the less. So if it's 1, you're just taking the last value. Whereas if it's closer to 0, you're sort of averaging that out across the data set and you're weighting the earlier values more heavily. And they correspond to the model there. So alpha is the level, beta is the trend, and gamma is the season. All right. So, sure. So alpha is the level. That's essentially where it's going to start the first point in the forecast. Beta is the trend. That's the coefficient for the trend. And gamma is the coefficient for the season. So the closer to 0 it is, the more it's going to consider those older values, and the smoother it is. And the closer to 1, the more abrupt the changes are going to be. MAPE is the, I believe it's the mean absolute percentage error. So all of this, I will point out, you saw there was a link in all of the forecast windows. There's a link there for Learn More. And we have excellent documentation online that explains in much detail what each of those are. So the MAPE is the mean absolute percentage error. So MAPE and MACE, which is the mean absolute scaled error, are probably, those are very popular forecasting, probably more so MAPE than MACE. However, as you'll see, this MACE value is not, it's more robust. So when the MAPE value is dealing with zeros, it doesn't deal with zeros very well, and it actually puts more weight for extreme values. So the MACE has some advantages over the MAPE. All right. Okay, so the one thing you would see if we go in and note the AIC value, you'll see that that's 597, and the MACE is 0.5. So if we go back to the automatic, and this is allowing Tableau to choose the best model, you'll see that this will have a lower or a higher AIC. So the AIC here is 584, and the MACE as well is 0.71 compared to 0.5. So even though it looks better to the eye, it does not exhibit that level of seasonality. And you can see that very clearly if you just rearrange the data. And by the way, forecasting does work with all types of dates. So here we have the date parts that we're using, and you can see that the forecast still works. But you can see very clearly here that at the monthly level, sometimes October is the lowest, sometimes it's the highest. There is no clear seasonality, so we in essence forced Tableau to show seasonality where there wasn't. However, if I roll this up to the quarterly level, you will see that Tableau clearly finds seasonality. So that is one tip. If you're not getting what you feel is Tableau's not sensing seasonality when you think there should be, for example, oftentimes if you go up to a higher level of aggregation, there will be clear seasonality at that level where there was just too much noise at that lower level. Okay. And I'd like to finish up by just pointing out a few things that could potentially go wrong, because I'm guessing some of you have created forecasts that either show an error, no forecast, or you get a straight line and kind of not sure how to handle those situations. So I ran into a similar issue when I was looking at my electricity data that I downloaded from my electricity provider. And I would think that with electricity, there would certainly be a lot of seasonality. So this data is actually down to the hourly level, but I'm going to go ahead and look at it by month. And what I had done was this October was a partial month, so I excluded that. And October 19, I don't remember if that was a partial month or not, but we'll leave it. All right, so I'm going to go ahead and create a forecast. And again, a straight line. Now I know that this should be seasonal. If I, again, look at it by year and month, it is very clear that there is seasonality here, but Tableau's not detecting it. So why is that? If I go in and try to force it, it will show me an error message. So let's do additive seasonality. So it says the seasonal model cannot be computed because the time series is too short. So for seasonality, for Tableau to use a seasonal model, it is required to have a full 2 seasons. And with this data set, I just happen to be 1 season short. So I can go back, and if I, on this data set, if I choose not to ignore the last month, that's the month I need, and Tableau shows me a nice seasonal forecast. If I look at describe, I can see that the quality is okay. I can see that I have a MACE of 0.41. So by that measure, I have 41% the error as a naive model. Going off of the MAPE model, I have 7%, so decent model. And I can see that it used a no trend for the trend and multiplicative for the season. So that looks pretty good. All right. So in review, uh-oh. Did I kill the PowerPoint, Joshua? File. Is this it here? Perfect. All right, thank you. Okay, so to review, Tableau forecasting uses exponential smoothing, which is a univariate forecasting method, meaning we'd only look at one measure, one variable to determine the future trend and forecast. You need a time series. Most often this is a date value, but it can also be an integer if you're representing a time series with integers. A exponential smoothing model has two primary components. Those are trend, which is the overall long-term trend of the data, as well as seasonality, which is a repeating component pattern that you find in the data. And both of these can be either none, multiplicative, or additive, giving you 8 or 9 potential models that Tableau selects the best from. And in order to determine the quality of the forecast, you are going to want to go to Describe Forecast and then look at the model. And it will show you, actually on the summary page, just a qualitative, poor, okay, good. And on the model page, it will show you the actual percentage errors that you can use to determine. All right. So I've mentioned some limitations with Tableau forecasting. So one is the single, you can only do univariate. Another one that I didn't get too much into is you really can't, there's many different forecasting, even univariate forecasting algorithms. Tableau, you're limited to exponential smoothing. And further, you can't tune or, for example, select, random varying seasonal patterns. So, and some of the customization's not there. So if you need a more complex model, that is where integrating Tableau with our external services, R, Python, and MATLAB come in, and that is what Josh is going to be covering in the second half.
Thanks.
All right.
Just give me 1 second, everyone. Okay. Oh, stop. And there we go. Okay, everyone, let's give it up for Jason. All right. So I want to kick off this next section with a question. So out of these activities on the screen, what do you think the most people participated in last year? So either golf, participating in fantasy football, and this is inside the US. Golf, fantasy football, attending a Major League Soccer game, perhaps going to Disney World, or attending an NBA game. So just shout out some thoughts. 2, football, okay, all right, good guesses. So the actual answer is fantasy football. Now, why do I bring this up and to talk about multivariate forecasting? Well, I love fantasy football. I've been in the same league with some friends from college and coworkers and some of our spouses for probably like the last 14 years now, so quite a while. And I was fortunate enough, for the first time ever, to actually win the league last year. Thank you. So I participate, for those of you a little bit unfamiliar with fantasy football, I participate in what's called a keeper league. And essentially what that means is that you can choose to keep the same players year over year if you want to. And given the fact that I won the league last year, I was like, awesome, I'm going to keep my entire team, basically. And this is actually, you see on the left-hand side here, this is my record, so my win-loss, the score, the weekly score, and then the actual week. I thought, well, what if I were to use that forecast or that univariate, essentially total points scored from last year to help determine what my record might be for this year? So looking at something maybe a little bit more like this. How many people think that that method alone would be a good method for determining what my total points scored and then potentially my win-loss ratio might be for this year? No? I'm seeing a few head shakes. Yeah, it's not a great method. This year has not been as kind to me. I mean, things happen in fantasy football all the time. You know, players change team. Players get hurt. Their coaching changes. Certain quarterbacks forget that their job is to throw the ball to the people on their team. And so with that, when you have to account for these multiple variables, you need to sometimes use some of these external services. And that's really what we're going to be covering today. So how does it work? Well, we've actually been doing external services inside of Tableau for quite a while. We started back in version 8.1 with integration to R. In version 10.2, it was Python. In version 10.4, it was MATLAB. And most recently, in version 2019.3, we allow you to add both R and Python scripts to your Tableau prep flows, and we'll see that a little bit later. Now, for those of you maybe a little bit unfamiliar with some of these programming languages, R is really more of a very standard statistical programming language used for linear, nonlinear modeling. Python tends to be a little bit newer, but it's very easy to read, very easy to get up on, so it's become very popular as of late. MATLAB tends to be used more for computational analysis, so I see it used by a lot of scientists and engineers, used for things like thermodynamics, et cetera. And then as we discussed, 2019.3, you can use both R and Python. And this is great because for many of these languages, you don't have to be an expert in the language itself. You can go out, grab someone else's library, particularly with R and Python. They have a great open source community. Grab someone else's code, take it in, reverse engineer it, just add your data, and you can look smart like they were. So how does this work actually inside of Tableau? Well, inside of Tableau, and this will work exactly the same on desktop as it will on server. So inside your workbook, you're actually going to have a script function. And the script function essentially does two things. Number one is that it allows you to actually input code, which we'll then call out to, will be used by that external service. And we'll talk a little bit more about what these external services are in just a little bit. From there, you're also going to pull in data from whatever data source you've already connected to inside of Tableau. So it'd be a database system, SQL, an extract, flat file, so on and so forth. Using that script function, you're then going to pass both that data and that code over to an external service. And basically, an external service is something that it's just waiting, it's just listening to have this code received with the data. And so in the case of R, as we'll see today, I'm going to be using what's called rserve. In the case of Python, you'd be using what's called tabpy. And in the case of MATLAB, you'd be using what's called MATLAB server. Now, as we shall see, I'm actually going to be running this locally on my machine. I'm running R locally on my machine. But most often in kind of like an enterprise production environment, you would have an external server set up to run whatever this external service along with that program as well. So it'd be like something like tabpy server, R server, something like that. So that data gets sent over to that external service with that code. It actually gets run in that particular program, and the result set gets sent back to Tableau in the form of a table calculation. And what's really nice about this is once that data gets back to Tableau, you can then actually play with it just as you would any other data set inside of Tableau. So let's break down this actual script function just a little bit. There are essentially 4 different kinds of script functions that you can have. What's called script integer, script string, script boolean, or script real. And essentially what this does is it tells Tableau, hey, whenever this data comes back from whatever this external service is, this is how I want you to treat it. So either as an integer or string value, a true-false statement, which would be boolean or a real number. From there, I actually pass in whatever code or formula library I want to use. And inside that code, you're going to start seeing different arguments. So things like .arg1, .arg2, so on and so forth. And these arguments correspond directly to data that you're actually sending over from Tableau. So let's just go ahead in and see what this looks like. Now here, I'm actually looking at Johnson & Johnson's earning data from 1960 all the way out to roughly 1980. And I just want to create a forecast using one of these external services. So I will drag out my column, my date column, and I will drag out my forecast, and I'm just going to show whether or not it was my predicted versus actual on color. And there we go. That's it. We can all go home, right? So it's a little, sure. So it's a little more complicated than this. There's actually a little bit more that's going on underneath the hood. Let's take a look. If I look at my forecast function, what I'm doing here is I'm actually using the script real function, so I'm expecting a real number back. Inside of R, I'm actually using the forecast library. So that's the library that I've downloaded and installed in my local R machine. I have a couple of print statements here. These are really, they're not really used for the formula itself. This would be particularly if like I was running R in a debug mode or something like that, and I wanted to see exactly what was getting transitioned back between Tableau and that external service, in this case R. So if I had to do some troubleshooting if the numbers don't look right. Then below there, this is my actual statement that is getting run by R. So I've got a forecast statement. I've got different arguments in here. I'm accounting for some time series values here. And as you'll notice, you have the .arg1 and .arg2. And this corresponds, as I mentioned, directly to the variables, the data that I'm passing via Tableau. So my sum of earnings and my periods to forecast, which is a parameter. And this is all made possible because I've set Tableau up to look for that external service connection. So if we go up to Help, and then Settings and Performance, Manage External Service Connection. Here I'm running RServe locally on my machine, so you can see that the server is the local host, and the port is 6311. And then on the R side, I'm actually using RStudio, which is just a popular program to run R code. You could use something else. But I've actually downloaded the RServe library, and I've actually started running it in debug mode, which is that true statement right there. So now as I go ahead in and interact with this parameter here, let's say I want to forecast out 16 periods. Instantly, what Tableau is doing is it's just doing that same thing over again. It's taking that R code, taking that data, sending it to that external service. It's getting run inside of R. The data is getting sent back to Tableau. And now we've got a beautiful forecast. But for some of you who might be kind of like looking at this, you might be saying to yourself, well, that's great, Josh, but I mean, at the end of the day, that's still univariate forecasting. Isn't that what Jason just showed us? And you'd be right. So let's go ahead in and let's dig a little bit deeper. In this next example, we're looking at data from a call center. And what we can see in the blue lines here are the actual call volumes. And these correspond directly, we see a spike directly after each holiday, which is signified in the bars right here. So we have a holiday, then we have a spike, and then we have a pretty big drop-off. Now in this first example, I'm actually just using a very simple univariate forecasting function here. So if I quickly show it to you, again, nothing mind-blowing here, script real, calling out the forecast library. This is my actual code that's getting run, using this average call volume as my univariate forecast, or my univariate measure. And while it does forecast out into the future, we can kind of see that right here. What we don't see is that spike that we would expect to see. And so for that, we actually need to take into account the holidays, and we need to train our model to better account for that. So for this, I'm actually going to be using what's called an ARIMA model. So I'm actually still calling out the exact same forecast library here. And inside these libraries, you can have multiple models, functions, and these correspond to just different statistical calculations or methodologies that you want to use. So in this case, I'm using the ARIMA model. And ARIMA stands for Autoregressive Integrated Moving Average. Basically, what that does is, depending on which ARIMA model you choose, what that allows me to do is to better take into account these multiple variables, in this case, this holiday seasonality here. So I'm passing in my functions. There's my ARIMA function right there. I'm training my model. I've got my second argument right here, which is my average holiday. And using this model, we actually do see that spike that we would expect. So when you start to use these multiple variables, you can better train your models to understand and get a more accurate prediction. And what this allows you to do is we begin to see this marriage between data science on the one hand and ease of use for the business user on the other. Because for many of your business users, while many of them may be experts in their field, many of them might not have a PhD from Data Science University, but they don't need one. And for those of you out there who are data scientists, what this allows you to do is actually take these more complex models that you've developed, use that, whatever that programming language is, R, Python, et cetera, and give those models to your business users so they can begin to do their own kind of what-if analysis. As I like to joke sometimes, a business user doesn't need to tell me or describe for me the actual formula for standard deviation. And I'm not talking about I don't mean just sigma or the square root of sigma squared. I'm talking about like the actual formula to write it out. So you don't need to actually tell me that to understand what is standard deviation or appreciate the impact of that. And so as we continue on this road, we start to see business users really want to do their own kind of what-if analysis. And that's what we're seeing here. So in this example, I work for a website company. We sell software. And we have sales. People come to our website. They decide to download our trial software. More trial downloads equals more sales, so on and so forth. You get the gist. But times are tough, and we're thinking about temporarily suspending a marketing campaign for a brief period of time. And so I work on the marketing team, and I'm kind of wondering, I'm using this model that one of my data scientists has built me, and I'm predicting that if we temporarily suspend this marketing campaign, we're actually going to see roughly about a 10% decrease in website hits. So I'll just go ahead and make this -10. But to better counteract for that, because we can anticipate that that's probably going to happen, I'm going to work with some of our developers, and we're actually going to move that trial download button to different parts of our website. And as a result of that, we're estimating that we're probably going to see about a 10% increase in trial downloads. So I'll go ahead and start to run this. So again, predicting 10% decrease in website visits, but we're trying to counteract that using a 10% increase in trial downloads because we're actually moving the actual download button. So what we shall see here is this is our decrease in website visits. We've picked that up. This is our increase in trial downloads, so good. But we actually see a 10% decrease still in sales. And because I'm an end user and I'm a marketing guy, I don't necessarily need to know the data science behind this. All I need to know is that one line is lower than the other. And so now maybe we want to think about other alternatives as opposed to any of that marketing campaign. Up to this point, however, we've talked a lot about what do we want to do for decisions that we're going to make in the future, okay? How do we help justify those? But sometimes what you need to do is help justify decisions that you've made in the past. So in this example, again, I work for a company, and people come to our website. We sell sweaters. If anyone's familiar with Chicago right now, it's really cold. So as the temperature goes down, sweater sales go up. And on a particular date, we decided to run a marketing campaign, and thankfully, because I'm a marketer, we can see that our sales increase. So kudos. However, it's not that simple. In order for me to better justify the cost of this marketing campaign, because there is a cost, I need to better predict what would have happened had we not actually decided to have that marketing campaign. So for this, I'm actually going to be using a causal impact library. And if we take a look at this function here, I'm still using the script real function. I'm passing in to this causal impact library multiple arguments, but one of the things I'm doing is I'm actually defining a pre and a post period. So this is before my marketing campaign and after it. So I'm helping to train the model. And then I'm actually passing in multiple variables. So in this case, what were my actual sales pre and post? What were my actual website hits pre and post? What was the actual temperature pre and post? And as a result of that, if we take a look at this model, we can actually see this nice little red line now. And this red line here corresponds to what would have happened had we actually not run that marketing campaign. And if I hover over this line, I get this very rich statistical story about what's actually going on at any given point in that data set. And this is not Tableau actually generating this line. This line was actually generated via that causal impact report. So if I look at the summary here, which is on my tooltip, you can see that I'm actually essentially calling the same library, doing a lot of the same analysis. But here, I'm actually pulling out this impact report here. I'm doing some regular expression magic, but this is what actually gives me that nice little tooltip data set. Now, seeing that line is great, but somebody's going to ask me, well, yeah, I can see a line, I can see there's a difference. I need a number, okay? Don't show me the line, I just need a number, right? What was the final cost of that, or the final delta of that? And so for that, I basically need to run a running total of the delta of that line, and that's what we see here. So I'm still using the causal impact analysis report, the causal impact library. Passing in much of the same features, I'm defining a pre and post period. And then I'm actually doing a running total. So this is my beginning of my marketing campaign, delta, 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 adding this up. And now we can see that as a result of this marketing campaign, I can take this back to my business and say that we generated roughly about $748,000 in sales from what we would have generated had we not run this marketing campaign, all because I can do this kind of analysis using these external services. Now, I want to take a quick moment and just step back in and touch on something that Jason kind of talked a little bit about at the beginning. So number one is, all these are sent as table calculations, okay? And when things are sent as table calculations, they're highly dependent upon the level of detail of the view, and then also the filters that are getting applied. So you need to just kind of be aware of that. The other thing, as Jason mentioned, is that we need data for that external service to send something back to. Now, if I don't want to union that data, there are a few other methods that I can choose to actually make this work for me. The first is called date shifting. So this is my original data set up here. And what I'm going to do is I'm actually going to trim data off the end and shift it to the right, nulling it out. So essentially, I have data for that external service to send it back to. So what this looks like is I basically go in, and I decide, okay, I'm just using a very simple date add function here to add the number of periods onto my forecast at the quarter level. So we'll just drag this out at the quarter. We'll look at my forecast and predicted versus actual, and there we go. But the one thing you'll notice here is that if I hover over this last point, I start at 1964. My data originally started at 1960. So as we can see, we've actually trimmed off that data and shifted it to the right. Now this works very well if you have a very long tail of data that you can afford to actually cut off. But sometimes you might not have that, or you might just not want to use this method. So another method is using what's called domain completion. And for this method, the very first thing that I need to do is I'll just kind of show you what my data looks like originally. So this is my quarter. And we'll show my earnings as a bar chart, so everything's there. The very first thing I do is I calculate a max date. So just using a fixed LOD label calculation, I'm just saying, what is the maximum date as a quarter of my data set? From there, I say, okay, well, given that, if it's equal to the max date, I'm going to add on this number of periods to forecast, else show the quarter. So when I drag this out, I'll show them side by side. We can see here that I have now this little area right here where data needs to go into, okay? If I drag out my forecast statement, I'm actually going to put this here and take this one off. No data, no forecast, okay? Well, something went wrong. The trick here is if you're going to use this domain completion is you need to check here and you should use this show missing values. What show missing values will do is it will essentially null out those values, but they're still sitting there waiting for Tableau or waiting for the external service to send something back to. So if I drag out my domain completion forecast here, now I have data all the way out. I can switch this to a nice little line, and my predicted versus actual, and there we go. So I just quickly want to touch upon what this might look like if you were to do this in Tableau Prep. This is not a class on Tableau Prep. There are a lot of great classes on Tableau Prep. But what I've done here is I've just taken a very simple flow, and I want to do some probability calculations based off some customer satisfaction scores. So I'm bringing in that data here. I'm doing some cleansing. But to any step in my prep flow now, I can actually add a script calculation, which is what we see here. So if we take a look at this script calculation, basically what I'm doing is I'm using RServe. I've connected it to my R server. this is the actual file, so you need an actual file with R code in it to actually pull back data from. And that file looks something like this. So this is the actual code that I'm running. And I'm using this get output scheme to essentially pull data out of that return value to then use as in Tableau prep. And now I can actually add this to any point in my flow. So just quickly to recap, we talked a little bit about what we can do using our external services, in this case Python, MATLAB, et cetera. We talked about how we can use parameters to really expand that multivariate analysis to our end users so they can do some own what-if analysis. And then what can we do if we want to do some impact analysis? How might we better understand that? Now, we are kind of like right at the end here. So, do you want me to?
So we do have, this afternoon, there are 4 more sessions related to advanced analytics forecasting. We've got Get It On, Stat, Statistical Analysis Skills in Tableau at 1:15. Are You Ready for Python at 1:15. Tableau plus Python. Python's pretty popular at 1:15. And then at 2:15, even more data science applications in Tableau.
So I know you've probably heard this from all the sessions you've been to. Please, please, please go into the mobile app, fill out the session survey. We really do look at every response. It helps make these sessions better year over year. And with that, we just, on behalf of Jason and myself, just say thank you. Thank you for coming to the session. Tableau conference for people like us is really like Christmas, just to kind of come here and geek out about things like Tableau with 20,000 of our closest friends. So really do. Thank you. Jason, I know we're right at time here. Jason and I will be up front just for a little bit. If you have any questions, come see us. But thanks, everyone.